Okay, so let us start our discussion by talking about potentiometers. Okay, so potentiometers are basically um, resistance sensors which changes its resistance in response to displacement. Okay, so um, here's a picture of the potentiometer on the screen, and the basic idea here is that so there would be three pins associated with this potentiometer. Okay, and as this wiper moves up and down, the resistance between one end of the potentiometer and the pin that is connected with this wiper would change. Okay, it is described schematically here. So think of this as a resistor, and as you move this wiper, the resistance between the bottom of this sensor and the wiper is going to change. So this displacement X is going to be proportional to the resistance Rx. And that's how this sensor works. So what's the principle of the potentiometer? A potentiometer can just basically be a straight wire, right? So this resistance could just be a straight wire. And we know that the resistance actually depends on the distance between the bottom of the wire and the wiper, right? How is the resistance related to X? It is related by this equation, rho over A times X. So the resistance Rx and X are directly proportional to each other. More practically, however, we don't just have one wire making a potentiometer, but what we have is something like shown here in the schematic. You have a spool around which a wire is wound, and then as the wiper moves, there is more change in there is more length of wire that goes between any two points as the wire moves, right? So as the wiper moves here, it goes from this point to, let's say, this point. So it's not just a very small length of wire, but there's a longer length of wire that that increases. And what that means is that you will have a larger change in resistance. Of course, what this does is you here I have drawn a very sparsely wound spool. Usually, the spool is much tightly wound, which means that we can measure very small displacements. But even if you can measure very small displacements, we know that the resolution of displacement measurement is not infinite in this case, right? Because you can only measure resistances that go from this point to this point. And if it was a closely wound wire, it would be smaller, but it won't be infinitely small. Unlike in this case, where if you just have a straight wire, you can have a very, very small displacement and you should be able to measure it, at least theoretically. Of course, practically, probably it does not make any difference because the resolution of a potentiometer with just a straight wire is limited by noise. And so, probably, even if there is a very small displacement that theoretically you can measure, practically, in the presence of noise, you may not be able to measure those very small displacements. Okay, so let's ask a question about calibration of potentiometers. How are we going to calibrate potentiometers? Do you remember what calibration means? Calibration is how do we find a relationship between the displacement and the change in resistance. Okay, so as we displace this wiper up and down, how does the resistance change? We want to measure it, and that's what calibration means. Um, of course, in this case, it almost seems as if we've already know what the answer is, basically because we've got it from first principles, from theory. But in many cases, you don't know it. And even if we know it, there may be variations because of non-idealities of the way in the way that potentiometers are made. For example, there could be small changes in the width of the wire along the length, which could change its resistance in unpredictable ways. So you want to measure it. So how would you do it? Well, the answer is fairly straightforward, isn't it? You basically change X and you measure the resistance at each point, and ideally you should get a line like this, a straight line like this. How are you going to then, if you do this, we'll discuss this in more detail in the next lecture, but I thought we could just talk about how we are going to convert this change in resistance to a change in voltage, which is what usually you would want, because change in voltages can be processed and you can do something with those voltages, um, and process it further, maybe filter it, maybe amplify it, and things of that kind. So how would you convert this resistance into voltage? One way to do it would be to just connect a voltage source across this potentiometer and measure the output voltage.